In question number 6, a small particle can slide in vertical plane from point A to point B along either of the two different paths shown in figure. This is path 1, this is path 2. Friction is absent. If time taken along the path 1 is t1 and along the path 2 is t2, then we have to find out the relation between t1 and t2. So, suppose if I kept a small particle here and here on path 1 and 2, then I can see easily the initial acceleration in path 2 is more as compared to the initial acceleration in path 1. So if acceleration is more, the time taken to cover path 2 will be less as compared to the time taken to cover path 1. So option 2 is the correct answer. So the correct answer for question number 6 is option 2. Let's move to question number 7. In question number 7, a man is running with a velocity of 5 meters per second towards north. If coefficient of friction between the ground and the feet is 0.2, then the minimum time in which he would be able to change its direction towards east such that its final speed is yet again 5 meters per second. And it is given value of g is 10 meters per second square. So if I analyze the situation, suppose initially the man is here and it is moving in the north direction with a speed v, and the value of v is 5 meters per second. So after some time it changes its direction from north to east in this way, and it is right now it is also moving with the speed v. So the only force which is acting on the man due to ground is friction, and I can say that the change in momentum is only because of this frictional force. So F into dt is equal to P final minus P initial. So if I write in vector form, this is like this, and if I take the mod of this, then I get the relation. So the value of F dt can be written as the mod of frictional force is mu into mg, and it is multiplied by dt, that is equal to m into v final, that is 5 into I cap, minus v initial, that is 5 into j cap. So m can be cancelled out. So from here the value of dt comes out to be 5 into root 2 divided by mu. The value of mu is 0.2 into g. The value of g is 10. So it comes out to be 5 by root 2 second. So option 2 is the correct answer. So the correct answer for question number 7 is option 2. Let's move to question number 8. In question number 8, a variable force F is equal to 2t plus 4 Newton, where t is in second, is applied on a block of mass 2 kg as shown in the figure. If mu is equal to 0.5, then velocity of particle at t equal to 5 seconds is. So first of all we have to understand at what instant this block will move. So the maximum value of the friction is half, that is 0.5 mu into normal reaction, that is 2 into 10. So it is equal to 10 Newton. So when the applied force is greater than the maximum value of the frictional force, at that moment the block will start sliding. So if I equate 2t plus 4 is equal to 10, so from here I will get the time instant at which the block will start sliding, that is t equal to 3 seconds. So if I calculate the acceleration can be written as 2t plus 4 minus 10, that is the net force in forward direction, divided by mass. So from here it can also be written as dv by dt, and the value of mass is 2 kg. So I can write dv is equal to t minus 3, and if I apply the limit of integration up to t equal to 3, the block is at rest. So from 3 to 5, let the block gain the velocity v. So on solving, the value of v comes out to be 2 meters per second. So option 1 is the correct answer. So the correct answer for question number 8 is option 1. Let's move to question number 9. In question number 9, in the given arrangement, the initial acceleration of block A is. So at this moment, if I want to calculate the acceleration of block A, so if I draw the free body diagram at this moment, mg is acting in this direction, tension T is acting in this direction. Let the acceleration of block C in this direction is AC. So if I see the tension acting on this block A and B, then tension T is acting in this direction, tension T is acting in this direction, and tension T is acting in this direction. Similarly, tension T is acting in this direction, and this block B, this T and T, that is 2T, is acting in this direction. So 3T horizontal force is acting on block A, as well as 3T horizontal force is acting on block B. So if the acceleration of block A is A, then the acceleration of block B must be equal to A. So if I write F equal to ma on block A, then I can say that 3T is equal to 2m into A, because this surface is smooth. So this is my first equation. So if these two blocks are moving towards each other with an acceleration A, then from the equation of constraint of this string, I can say that AC must be equal to 6 times A. So if I write F equal to ma on block C, then I can write mg minus T is equal to m into 6A. So on solving these two equations, I will get the value of A, and the value of A comes out to be 3 by 2 meter per second. So option 1 is the correct answer. So the correct answer for question number 9 is option 1. Let's move to question number 10. In question number 10, a particle is projected from ground with velocity 20 meter per second. If range is 3 times the maximum height, then magnitude of maximum change in velocity is. So let's analyze the situation. Suppose this is the particle and this is projected with a speed v, and it is given that the value of v is 20 meter per second. So this is the projectile. Now the question is maximum change in velocity. So we have to calculate the maximum value of delta v. Since the horizontal component of the projectile will remain constant as no external force acting in the horizontal direction, so the maximum change in vertical direction comes at this point to this point. So it is equal to 2v sine theta. So now we have to calculate the value of theta, that is the angle of projection, and we know that the standard relation tan theta is equal to 4h by r, and it is given in the question the value of r is equal to 3 times of maximum height. So it is equal to 4 by 3. So theta is equal to 53 degree. So from here the value of sine theta is equal to 4 by 5. Now I can substitute the data. 2 into 20 into 4 by 5. So on solving this, it comes out to be 32 meter per second. So option 3 is the correct answer. So the correct answer for question number 10 is option 3. Let's move to question number 11.